In this video, I'll be covering question 1, part C from the 2012 AP Calculus AB Free Response Calculator Required portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. Alright, so C is telling us that on this interval from 0 to 20, they want us to find the average temperature in this water. And they give us the formula here. They're kind enough to give us the average value formula already set up. And then the piece that we have to take care of to get going is we need to do a left-hand Riemann sum with 4 subintervals, and that's basically going to take care of the integral portion of that formula. And then once we have that done, we'll talk about the rest, which is how to determine if that is an over or an underestimate for the average. So whenever I am doing a Riemann sum off of a table, I pull that table onto a number line. I do everything I can. I always call it test brain. Your test brain does not function the same as your normal brain. So I start off by taking what I, just refer to as the x values, and I mark off my number line. So 0, 4, 9, 15, and then 20 down here. And then after that, I come through and I mark all the y values that go with them. So at 0, I have 55. At 4, I've got 57.1. At 9, I've got 61.8. At 67.9, at 15, I got 67.9. And at 20, I have 71. And then I come back and I mark these little gaps. I would say that's going to be area 1, area 2, area 3, and then area 4. That really just helps make sure that I've done what they want, that I've got my 4 subintervals that they're looking for. And then I just call this my assembly line process. So I'm going to come through. This is going to be A1 equals, A2 equals, A3 equals, A4 equals, and then we're going to add those up. When we're doing a Riemann sum is the area of a rectangle. So area is base times height. The base is always going to come from what they call the delta x, the gap in between your subintervals. And one of the reasons that I like pulling this out onto a number line is it really lets me see, especially off of the tables, when I have non-standard gaps. So for this first one, the gap would have been 4. On the second one here, our gap is 5. On the third one here, our gap would be 6. And on the last one here, we're back to a gap of 5. And so then I put those in my little formula. So then A1 would be 4, A2 would be 5, A3 would be 6, and then A4 would be 5. And now what we do is we come through, and the heights are going to come from the y values from these areas. So we're looking again at a left-hand Riemann sum. So I start off on A1. I've got two choices. I've got a left side and a right side. I want the right endpoint, so I'm going to choose 55. Then on A2, same idea. I've got a left side and a right side. I'm looking for the left side, so I will choose the 57.1. On A3, we've got our left, we've got our right, we want the left, so that would be times 61.8. And then on A4, we've got a left side and we've got a right side, we want the left side, so we would choose 67.9. Now, to get our approximation for our integral here, so our 0 to 20 of WT dt, we are going to just add up all of that work right there. And so what we do then is grab hold of our calculator, because this is a calculator required section, and we just put that work in. So for the first gap, this would be 4 times 55. Add to that the next gap, 5 times 57.1. Add to that the next gap, 6 times 61.8. And then add to that our fourth gap, which is going to be 5 times 67.9. So then out of there, I get 1,215.8. And then I need to remember that this is an average, and so I need this 1 over 20 portion up front. So 1 over 20 times our integral from 0 to 20 of w of t dt is going to equal 1 over 20 times that number we just got out of our calculator. And so then you would just grab that number, say 1 divided by 20 times, and then reach up and grab that answer, and we get 60.79 degrees Fahrenheit. So that's our average value right there, our average temp. And then they want to know, is this going to be an over or an underestimate? And so what that's going to be based upon is whether or not our graph is increasing or decreasing. And if you forget, again, like, it's very straightforward to kind of put together just a simple drawing. You don't need to know the exact drawing, because all things that are increasing are going to have the same outcome as far as over or under, and all functions that would be decreasing are going to have the same outcome. Once I draw the picture I'm looking for, so this one here is what we want, because it says up in the language, and this is what you would want to go hunting for. This is telling us that our graph is strictly increasing. So we know we're looking at this left option. And I just draw one made up little subsection, because it doesn't matter. All increasing functions will behave the same. If I draw up from the left endpoint and hit my graph here, I can see that when I draw my rectangle, what I end up with in this situation is an underestimate. And so for our problem, that's what we want. Just to show you what the decreasing, if I was doing left and right, if I drew up from the left side on a strictly decreasing, you can see that no matter what that function is, that would have been an overestimate. So ours is going to be an underestimate. And what you would want to do here is you would kind of just want to give them a little bit of an explanation in a sentence. You would say the approximation is an underestimate because W of t is a strictly increasing function. And they use that language in that problem up at the top. So when we go through this, you might want to say it's an underestimate with the left hand Riemann sum. Put that in there because W of t is a strictly increasing. So that would be our sentence. We would have gotten 3 points on this. You would have gotten 1 point from getting out your left-hand Riemann sum set up. You would have gotten 1 point out for getting that final answer for the average. And you would have gotten 1 point for putting together that sentence justifying why it's an underestimate. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.